The table below shows the age distribution of 50 pupils in a secondary school. Now, so the board asks us to look for the variance and the standard form, giving us a table. Here, the table, you have the age of the pupils and you have the numbers of the pupils. Now, in this question, I came with my calculator, as you can see, scientific calculator. We used to trash base. Now, we find the variance. I'll be using the tabular method to solve this question on the board. Using the tabular method. Then how do I solve this? First of all, you draw your tables. I have my table on the board. And on the first table, you put your X, which represents the age of the pupils. The next table, you put your F, which represents the numbers of pupils, which is the frequencies. Then the next one, you have your Fx, which is the frequency times the given values, which is the X. Then your next one, you have the given value, which is the X, minus the mean. After that, you have your given value minus the mean square. The next one, you have your frequency times the given value minus the mean square. After you've done this, you underline. Now, after we've prepared our table, the table is being prepared. After preparing the table, you go to the value where you have the age of the pupils. You list them here on the X. The first age is your 10. The second age is your 12. The next is your 13. The other one is your 14. You have your 15 and your 16. Now, after listing them, you have listed them, then you go to the frequency. The frequency is your 18, your 4, your 6, 12, 6, and 4. Now, after listing the ages which I've done, you list the frequencies here on the board. Now, let's go to the next table. What is the next table? The next table there is Fx. You use the value to multiply the frequency. Now, let's multiply this. In multiplying this, you have your 10 times 18, which will give us your 180. Then the next one, you have your 12 times your 4, which is your 48. And you have your 13 times 6, which gives us your 78. The next, you have your 14 times 12, which gives us 168. Then the next, we have your 15 times 6, which is 90. The 15 times 6, 90. Then you have your 16 times 4, which is the last one, giving us 64. Now, if you watch, we've gotten the Fx. How did we get this Fx here? We've used the given value, which is the age of the children, to multiply the frequency, the numbers of the pupils, now giving us the Fx. So after we arrive at the Fx, first of all, we need to get the total sum of the frequency and the total sum of the Fx. Already they told us that the table below shows the distribution of 50 pupils. Already we know that if we are to add up all these, when we sum up all these, it will give us 50. Because already from the question, there are 50 pupils. So when this is being summed up, it will give us 50. Now, when we sum up this remaining one, Using our calculator, you have your 180 plus your 48 plus your 78 plus your 168 plus your 90 plus your 64, which will give us your 628. 628. So after doing this stuff here on the board, now we need to look for our mean, because after this we're about going to the next table, which is your given value minus the mean. Now we have a question: how do we get the mean? Because already we have our given values here, which is your 10, 12, 13, 14, 15, and 16. Now we use it to subtract the mean. How do we get the mean? The only way you can solve for the mean is by using your fx to divide your f. Using your fx to divide the frequency. How? Now, coming to this side, you say your mean is equal to the sum of fx over the sum of f, the frequency. Remember, we are solving for the mean. So we'll say our mean is equal to the fx is 628 divided by the frequency, which is 50. So when we divide it using our calculator, you have your 628 divided by 50, which will give us this mean is equal to 12.56. But I want us to approximate. If we use the approximate value, it will give us 12.6. So our mean is 12.6. That is our mean. Now, having gotten the mean now, we can now be able to solve for the next table. What is the next table? The next table is the given value minus the mean. How? Remember, our given values here, we have listed them. You have your 10, 12, 13, 14, 15, and 16. We'll use all the values you're seeing here now to subtract this mean. Anything you have, you put it here. Now, first of all, we have our 10. 10 minus the mean. You have 10 minus 12.6 will give us minus 2.6. So write our minus 2.6 here. Now what's the next value? You have your 12. Our 12 minus the mean. You have 12 minus your 12.6, which will give us minus 0.6. Now what's the next value? Our next value is 13. 13 minus 12.6. 13 minus 12.6 will give us 0.4. Now what's the next value? Our value is 14. 14 minus 12.6. 14 minus 12.6 will give us 1.4. The next one is 15 minus 12.6. The 15 minus 12.6 will give us 2.4. Now what is the last value there? The last value is 16. 16 minus 12.6. You have 16 minus 12.6, which will give us our 3.4. We are done with this table. So what is remaining now? We have the other tables. Now look at the other table here. We have your given value minus the mean, squared, all squared, all squared. It means that we'll square the answer of the answer we have here, of these values you're seeing here. All the values you're seeing here will be squared. After you've gotten the answer of it, you place it here. How? It means that it will be minus 2.6 times minus 2.6. Minus 0.6 times minus 0.6. It will multiply itself twice. Then the answer goes here. Now how? Now let's do it. Minus 2.6 times minus 2.6 will give us 6.76. You've seen it? Now the next one, minus 0.6 times minus 0.6 will give us 0.36. 0.36. Now the next one, 0.4 times 0.4 will give us 0.16. Then the next one is 1.4. Then we have 1.4 times 1.4, which will give us 1.96. We have our 2.4. 2.4 times 2.4 will give us 5.76. Then the last value is 3.4 times 3.4, which will give us 11.56. Now we've gotten this. That's the last value of it. Now in the last table, we have the last table over there. Now what is the last table? The last table is having a frequency times this value. Remember, this value, we have a given value, which is the x, minus the mean, which we've just finished solving right now. Now you have a frequency there. It means that you're using this frequency, which is this frequency here now, to multiply everything you have here. That's the meaning of this. Frequency times the value of all this. So our frequency is 18, 14, 6, 12, 6, 4. You're using all the values here to multiply everything here to get our answers. So using the same your calculator, scientific calculator, we multiply. We use our 18 times 6.76. Our 18 times 6.76 will give us 121.68. That is the answer. The second one is 4. 4 times our 0.36 will give us 1.44. We have the next one, 6 times 0.16. 6 times 0.16 will give us a 0.96. Then with the next one is 12 times 1.96. 12 times 1.96, which will give us 23.52. Now the next one is 6 times 5.76. 5.76 will give us 34.56. Now the last one is 4. 4 times 11.56. Then you have your 4 times 11.56, which will give us a 46.24. Now we've covered up the tables. We've completed the tables. Now what will be the next thing we do now? You see the last one there, which we just rounded off right now. We'll sum all of the figures we have here to get the total answer, because this will help us to solve our variance. Without the total answer of everything here, we cannot solve for the variance. We're going to sum all of these. We'll sum them together to get our final answer. Now we do it together. The first one is 121.68 plus 1.44 plus 0.96 plus 23.52 plus 34.56. We have our plus the last one now, 46.24, which will give us 228.4. If you're just joining us, I would like you to have your working materials. So as I'm multiplying, you there having your calculator, your pen and paper, you can as well join me to calculate, to check these I'm doing. Thank you. Now, having done this, we've summed up all these figures, and it gave us these 228.4. So with this now, we can be able to answer our question. The question says find the variance. Find the variance. Now, with the help of this, we can look for the variance. Now, let's search for the variance. Before we can be able to search for the variance, we need to put the formula for variance. Now, what is the formula for variance? We said variance is equal to, listen up now, we take this value here, because that was the reason we solve for this. This will help us to get the variance. You say sum of this value, sum of this value over the sum of the frequency. Sum of the frequency. Have you seen it now? So with the help of this now, we're able to get our variance. Now already, you might ask, what is the answer to this? Already we've solved for it. Look at it. We've solved for it, and they gave us this. So you have your 228.4 divided by, what is the sum of the frequency? Remember, our frequency gave us 50. When we added everything, it gave us 50. So you add your 50 here. Now when you divide, you say your 228.4 divided by 50 will give us a 4.568. That is for variance. We've gotten the variance. Now what's the next question now? The next question said the standard deviation. We've gotten the one for variance. Now standard deviation. How do you solve for standard deviation? We are being told that standard deviation is the root of variance. Standard deviation is the root for variance. So it means that our standard deviation is equal to root this summation f, open a bracket, x minus this square, all over summation fx. You see it? That's standard deviation. So we say our standard deviation will be, already we've gotten the answer to this. This is just what we just solved right now. And we solved to give us 4.568. Now we look for the root of it. Remember, you don't need to solve for this again. Already we solved for it and it gave us 4.568. So now the 4.568 we have here, we put it here with your root. Now you solve. Your standard deviation will be, using your calculator, you find the root of 4.568. Now the root of 4.568 will give us 2.13. Now when you approximate, 2.13 will give us, because you have 2.137 with your calculator. My calculator gave me 2.137. When you approximate to 2 decimal places, it gives us 2.14. That is our standard deviation. Thank you.